So students, on Friday, when some of you were out, we took advantage of the time to sort of go over functions, the big picture, like what is a function and what are all of the concepts that we need to know about functions. So we started with this one, f of x is equal to 2x minus 3. And we started, since it's not a word problem, we can pick any values that we want to plug in for x, our inputs, and see what outputs we get. So here are some that the students chose, starting with 3, and plug in 3. That's 2 times 3 minus 3, of course, is 3. 2 times 3 is 6 minus 3 is 3. And so these are the values that we got: 3, 3, 2, 1, -1, -5, 0, -3, and 7, 11. And here's our graph that I have pasted onto our OneNote screen. I look at the graph and I see what would be a reasonable interval for this graph. And my highest number over here for the y value is 11, and my lowest number is a -5. So I think I can just go by ones. We could have done twos, but that would give us a little small graph in the middle. And so if we use up the whole graph, we can. I see here that this graph is like 11 by 11. That was an accident. I didn't plan that on purpose. But anyway, so I labeled my 10s and -10s on each of the axes, x and y axes, which I realized after I forgot to label, but we'll label those in a minute. So I plot my first point, and here is 3 and 3. And I'm going to label that point. I'm not going to label every point because it makes the graph a little crowded, but you want to plot every point and label a fair number of them. At least 2 or 3 points need to be labeled, at least 2 minimum. And you could do a few more. So here I am graphing the points. 3, 3, and then 2, 1, and then -1, -5. I'm going to label that one. Make the graph a little smaller so we can see all of the points at one time. So we have 7 and 11 way up here at the top, and 0 and -3. So now that we have our points labeled, we can go ahead and draw a line. And we think, is this a continuous function or a discrete function? Do I need a line, or do I just need to leave the set of points? Well, there's no restrictions on this function. I could have chosen 1/2 or 1/4 or -0.2. I could have chosen any number I wanted as an input. Therefore, since this is a linear function with no restrictions indicated, we're going to need a line for this function. So here is our line. I'm just trying to make it a little better and a little thinner. So here's our line. We did have a discussion about whether or not we needed arrows on the end or just on one end, and since we said this, there is no restrictions on this function on the domain, that the domain would go on forever and ever in both the positive and negative direction, and so with the range. So we needed arrows on both ends. Great, and we said it was continuous. I'm going to skip forward a little bit. So it means it has a line. If it's continuous, you want to draw a line. All right, so our next point that we're going to talk about on this graph is whether or not it's linear or not. And we can see one of you asked at this point whether you would ever have a continuous graph that would not have arrows, that would not go on forever. So we went up to a different section when we talked about this and realized that sometimes that happens. For example, in this example, on problem 5 in section 4.6, and it asks us to identify a reasonable domain and range. And the problem says that a quart of paint will paint a certain number of square feet of wall. And it asks us to plot how many square feet could we possibly paint if we had 3 quarts. If we use somewhere between 0 and 3 quarts, how many square feet could we paint? Now we know that the amount of quartz we use is our independent, and our dependent variable is going to be the amount of area, because that depends on how many quartz we use. So in that example, we see that we can only use up to 3 quarts, so our domain would be 0 to 3. But since we can use 2.5 quarts or 2 quarts or 1.5 quarts, that we could have anywhere in between that point. So it would be continuous, but it could not go above 3, and therefore it would be would not have an arrow on the end, and it would still be continuous. So our next question is whether or not this expression, this graph is going to be linear or nonlinear, and we can see from the graph that it's linear. If I also use this table to figure out the increase of values between the x points and then again in the y points, we could see that this would be a constant ratio. We're not going to take the time to do that, but we could have done that. And the other thing we can look at is this equation, and you're going to learn in the next chapter that when the equation is in this format and the x value has the exponent of 1, that this usually indicates it's linear. And we're going to get in the next chapter when that would not be linear, but here we go. That's a linear function. And now we're going to talk about our inputs and inputs. We're going to talk about all the things that we know about functions. So our independent variable, I realize I misspelled that, and sorry about that, but I can't go back and fix it now. But independent, not independent. Anyway, x is our independent variable, y is our dependent. So our x is our independent and our y is our dependent. Now let's identify the domain and range. And the domain, remember that when they ask you to identify the domain and range, they were not asking you just to give the definition such as, well, it's all the x's or it's all the y's or the inputs or the outputs. They want you to say, what could those x's be? What are the values? In this equation, as we said several times, there are no restrictions on what our inputs could be. So therefore, it can be all real numbers, and it can go on to infinity in both directions. And our range, because our domain is all real numbers, and we have a linear function that's not vertical or horizontal, it's going to be all real numbers as well. You can write it all real numbers, or you can write it in this fashion as we did in the textbook already. Negative infinity is less than x, which is less than positive infinity. Our domains are our inputs, and our ranges are our outputs. We put in numbers for x, and we get out numbers for y. And another way to say that is this is our independent and dependent variables. So that's what we learned about functions. Remember that this is an equation. And when we have a real world function, we have to think about what's realistic for our domains and our ranges. If it's talking about the number of people, you certainly are not going to have negatives. If you're talking about time, you're certainly not going to have negatives. In fact, in that case, probably you might be working either just, in quadrant 1 or maybe quadrant 1 and quadrant 4, depending on what your range is. So we do have to make sense of the problem. We have to think about the problem and say, what does? Now, if you're studying for the test, you need to do the Math Excel test. That way you can actually check your answers. You can also do the chapter review. You can pick out odd number problems from each of the sections. There are lots of different ways you can study for the test. So please do so, and have a great rest of the day.